Hi, I am Jialing. In this video, I'm going to discuss about metrological traceability. First of all, let's have a look on definition of metrological traceability. Metrological traceability is the property of the result of a measurement or the value of a measurement standard that relates it to a stated reference, usually a national or international standard, through an unbroken chain of comparisons with stated uncertainties. There are two important items for a measurement to be comparable and traceable, which are stated reference and stated uncertainty. Stated reference is usually referred to measurement unit, measurement procedure, and measurement standard. And for stated uncertainty, it is the interval around measurement which contains the true value. It usually arises from the measurement process and reference. Now, let's have a look on how a measurement can be traced along a traceability chain. A traceability chain can be represented in a pyramid form with international standard on top of the pyramid, followed by National Metrology Institute, calibration laboratory, and finally a testing laboratory. When going up the pyramid, the accuracy of a measurement will be increased, whereas its uncertainty will be decreased when going up the pyramid. A testing laboratory will provide measurement service to a product. The accuracy of the measurement is validated by a calibration lab who provide calibration service for measuring instrument with a primary or secondary standard. This standard comes from a National Metrology Institute, and the calibration method is also validated by this institute. And lastly, all the measurements that made along the pyramid should be measured under an international standard, or we known as SI unit. How should we establish metrological traceability in an analytical lab? Metrological traceability is actually applied in daily or routine lab work, for example, during the preparation of standard calibration. The first step in establish metrological traceability is identification of measurement and target measurement uncertainty. The objective is to prepare cadmium standard calibration. The measurement is determined as concentration of cadmium in milligram per liter, and the uncertainty is equal or lower than 2 milligram per liter. After that, a suitable method and procedure is established. The surface of the high-purity cadmium metal is treated with an acid mixture to remove metal oxide contamination. The cleaning method is provided by the manufacturer of the metal to obtain the purity quoted on the certificate. 100 ml volumetric flask is weighed without and with purified cadmium metal. It is important to weigh the cadmium metal accurately with a mass approximate to 100 mg. The resolution of the balance is 0.01 mg. 1 ml of nitric acid and 3 ml of ion-free water are added to the flask to dissolve the cadmium metal. The flask is cooled and filled with ion-free water up to the calibration mark. The solution is mixed well by inverting the flask at least 30 times. The third step is the validation of method. Validation of method can be done by doing a cross-check between solution prepared by us and the solution prepared from different method or the solution that provided from National Standard Program. However, we should make sure that the solutions must have similar combined uncertainty. The concentration of both solutions is then compared by using an ICP or ES. Next, we should identify relative importance of the influence quantities. This is because uncertainty is usually arise from the influence quantities and thus have large effect on the result. It can be done by prediction from the formula given. The influence quantities include mass, purity, volume, and temperature. After identifying the influence quantity, we should choose and apply appropriate reference to make sure that every value in the measurement is traceable. This can be done by doing calibration on instrument, having certificate control on the material, and through method validation. To have a better control on mass balance is routinely calibrated and confirmed by associated calibration certificate. Linearity is checked with internal check wave to stay within the limit given in manufacturer certificate, and validity is further reviewed with daily check wave. Next, the purity of cadmium metal is certified by the supplier. The uncertainty is demonstrably small enough for the purpose, and the preparation is based on the instructions given by the supplier. For the control of volume, information of volume flux used is traceable to national standard through calibration certificate. The uncertainty is acceptable. Volume of the flux is checked regularly by weighing the given volume of water. And for the control of temperature, the laboratory temperature is monitored using thermometer with smaller uncertainty. Ordinary mercury in glass thermometer can check against a calibrated thermometer, and the flux is calibrated with water at temperature of 20 degrees. The last step is the evaluation of uncertainties for each influence quantities. We should assess and confirm the overall uncertainty meets the end-use requirement. From the graph given, we can determine that mass and volume is the major contribution of uncertainty and should be controlled and monitored well during the preparation of the solution. Note that the temperature uncertainty is included in the volume uncertainty. Let's have a look on the role of metrological traceability. Metrological traceability plays an important role for quality assurance and quality control program. This is because it allows a meaningful comparison between measurements over time and space. This is very helpful in decision making. For example, a comparison with a standard will help us determine whether our product or measurement achieves certain requirement or does not achieve. This will allow us to make decisions on whether we should reject or remain the current system or method employed. Apart from that, metrological traceability increases productivity and efficiency. Metrological traceability will help us avoid duplication of work, accident, and loss of resource. By doing so, we are able to increase trust between trading partners by assuring customer benefit and fulfilling customer requirements. Thanks for watching this video.